All right. Good morning, everyone. Welcome to this session about query understanding with LLMs, where we're going to be talking about search. So search technology and really the market around search has evolved in the past few years tremendously. We have seen the arrival of vector search, semantic search, all these things. And companies have tried to implement semantic search as a silver bullet. And this silver bullet is actually not working very well. So they are struggling. They are seeing that the search results are not as good as they would like to be at the end by only using semantic search. And this is something that has been acted upon with various techniques. So you can use something like re-ranking to act on the output to improve the relevancy of the search results. But this doesn't really work if your initial search results are not good. So these technologies are not, I would say, the full solution to having good semantic search in the end. At the same time, we've had large language models that have become very, very good at understanding content, at extracting information out of content. So today we are going to be talking about these large language models, how they can actually improve the input of the search results, because the input is something that if we have low quality input, you are going to have low quality output. So in this talk, we are going to be talking about the how to improve the quality of the input by using large language models. I am Cédric Pelvet. I'm a principal specialist solutions architect with AWS, and today we are going to also have Hajer, Bouafif, who is going to be presenting with me. Yes, so let's look at the underlying technologies that we have with OpenSearch. So we have multiple things, multiple layers, I would say, of search technologies. The foundations of what we have in OpenSearch is going to be the historical lexical search with BM25. This is where you are going to be dealing with synonyms, you are going to be dealing with exact match or something that's going to be close to what you have with tokenizers, analyzers, all these things. And this is what historically companies have been doing. This works really well for most cases. But if you want to introduce multiple languages, if you want to introduce more complex synonyms, semantic searching, all these kind of things, lexical search is not enough. Sparse neural search, or neural sparse search, is something that is going to be close in the execution of lexical search. So we're going to get an array of terms, of tokens, of words that are going to be extracted semantically going through a specific model. And you are going to have some weights in addition to the terms themselves. And this adds context. You have semantic context. This gets a bit better. It's actually very interesting in a single language, probably more than vector search in some cases. But if you want to deal with multiple languages at the same time, sparse neural search starts to get things, but still the vector search is going to be much better at multiple languages. Vector search is a way to really abstract the representation of the actual data. So you are going to be representing your documents or paragraphs, chunks of documents, and your search queries as vector embeddings. And these are numbers that are completely abstracting the representation of the meaning. So these are, I would say, the main things that we are going to see, the main building blocks of what we are going to see there. And then you also have hybrid search, because sometimes you want to have exact match. If you have a reference, for example, for a book or something, you want to have exactly this reference. And this is where lexical search is going to be shining. Vector search is going to be losing that in translation. But if you want to have semantics, you need vector search. So to combine these different techniques, hybrid search is able to give you basically a combination of the search results with some specific rules that you have to define. And hybrid search is going to help there. And then multimodal search is a way to search your data through different modalities, like, for example, through text, images, sounds, videos, any kind of modalities that can turn into a vector embedding. Multimodal search is going to be helping there. So on top of that, on top of this foundation, we have this like different plugins, different functionalities inside of OpenSearch that will help you simplify the usage of these. So on the left, we have the document processing with the ML inference processor. On the right, we have the also the search query and results processing with the ML inference processor. Basically, it's a way to abstract how to create the embeddings, how to use vector search internally by sending the original text, original data that you have. In addition to that, we have some very interesting plugins. One is user behavior insight, UBI, where we are going to be able to capture the link, the correlation between the input, what the user is actually inputting into the search box, and the actual output, what has been selected, what has been bought if you are on an e-commerce website. And gathering this information enables you to have a better understanding of what's happening. You can have analytics on that, and you can also use this kind of information to better re-rank your data. Your results. And this is where the ranking technologies is going to be helping. But as I mentioned at the beginning, re-ranking only helps if your initial search results are already having the relevant results. It's just going to be reordering the results. It's not going to be getting any new information out of your database. If it's not there, you won't be able to see it even if you have a good re-ranker. So we have LTR, learn to rank, we have Amazon personalized, we have multiple ways to re-rank there. This is very, very useful. If you want to personalize at the end, you have search results, and for some users, the number, like 3 items is actually the most relevant. Then you are going to be learning that and then proposing this item first on the next iterations. And then finally, on top of that, we have, I would say, applications that you find at the, like not necessarily inside of OpenSearch. You can do some of them inside of OpenSearch, but mostly you are going to see them in the application level. So everything that's going to be about query understanding, query writing. So query understanding is to be able to understand what the intent of the user actually is. And sometimes you have a discrepancy between what the user is actually thinking and what the input UX is actually enabling the user to write. Query rewriting is going to be to enable the system to actually improve the quality of the input. It could be rewriting with adding some filters that would be extracted from the input. It could be rewriting with better spelling. It could be rewriting by adding some semantic context. Query classification, this is where we want to basically like differentiate between users who want to like target something that's very, very specific, where some other queries may be targeting something that's more generic. Like some users will know exactly what they want to do, what they want to search for, and some users are like, well, I'm looking into this kind of thing, but I'm not exactly sure. So these kind of queries will target different underlying technologies, lexical search, vector search, neural sparse, through this kind of query classification. To evaluate the results, we can have LLM as a judge, offline, online. And then we can also have result summarization, mostly useful if you have, if you want to get some information about a lot of data. You can actually use an LLM to summarize. They are very good at summarizing information. Useful for your log analytics, for example. You can ask, okay, what kind of errors did I have yesterday? It will summarize everything and it will give you the answer for that as a summary. So the context is very, very important here. So I mentioned we are going to be talking about the input, mostly the input today, how to improve the quality of the input, and the context is very, very critical. So we have 3 main context parts. We have the user context, domain context, and the business context. If we are looking at a search engine, you have an application where you have some search, you have different users. These users will have different interests, they will have different goals, they will have different behaviors. And they will have also maybe some preferences, like I'm looking for cheaper items, or I'm okay with like luxury items or something. So these, depending on the user, understanding what the user actually wants ultimately by some context that can be captured in multiple ways that we are going to be talking about, we can actually add some information on the input that may not be captured by what the user is actually putting. They're not in their input say who they are. They're just going to be inputting what they want. Domain context is more about the industry, what's going on with the trends, product recommendations, everything that's there. For example, if you're looking for an iPhone, if the system knows that an iPhone 17 was announced yesterday, that would be very useful. You can bump that up. Otherwise, you would get different versions and not really useful. So domain context with industry-specific, domain-specific information can also be added to the global context to improve the input. And finally, when we have an application that does search, it is very, very common that the business itself wants to have some results that are going to get promoted. For example, if you are promoting videos like news, then you may want to have some of these latest news promoted at the top. Or if you are running a bookshop, you want some specific books to pop at the top. Or if you have some paid customers, like these customers who are paying to get advertisements for their products, they also want to be promoted there. So traditionally, if you want to do that with like search queries that you build for lexical search, you are going to have a very, very long search queries that is going to be optimized one way for the users, and then the business comes and say, I want to optimize this way, so they turn the query around and modify that, and then they say, okay, now the users are not happy with the results, so they modify the search, and then they have an insanely complex query that even the person who wrote this query, if they go on vacation, they come back, they don't understand what the query does. So this is a very complex situation where you want to optimize the search results based on different complementary or contradictory, in some cases, like uses. So in the demo that we are going to have, we are going to be focusing on the user context. And for this user context, let's have a look at an example. So here we have an input, and the UX is going to be very important here. If we have a different UX, for example, having a chatbot or something, the input will be different. But if we have a text box like this, the classical mental model around that is going to be, I'm going to input a few words. And having a few words is going to be a bit critical. And first of all, here we have 3 different people, and with exactly the same words that they could be inputting, they have actually different things in mind. And this is not the only problem, because if we are looking into semantic search, for example, if we are looking into like the embeddings, what's happening is that the transformer models have been trained on longer inputs to create an embedding. So you have usually sentences, you have like tens of words, and here you have 1 word, 2 words, 3 words. And if you have a low quality input, like a few words only, if you don't do something to improve this input, then the output, the embedding itself is going to be lower quality. You are going to see that your cosine similarity score is going to be 0.7, 0.6, 0.4, and then you are going to be having a very low threshold, which is going to be increasing the noise in your search results, which is going to be basically impacting the quality of the result. So we need to be able to actually act on this input based on some information that we have on these people. So here we have different intents, and to do that, we are going to be talking about or introducing the concept of personas for this kind of application. So a persona, first of all, probably you've heard of this term before. I want to emphasize that the persona is not a role. So a persona is not a data scientist. It's not a student. It's not a worker somewhere. It's a person. It's an abstract or fictional person that is going to be representative of a group of real people. And these people are the users of your application. So there are multiple ways of getting the personas, but basically see that as people that are going to be representing your actual users. And they will have different characteristics. These characteristics are going to be about behavior, about mental model, and about goals. And to actually have personas, there are multiple ways. So usually, to have good personas, you are going to have user research. So you have a UX team that does user research, and you get the personas, and then you know exactly who your users are. And these users may vary per country. They may vary, like if you are worldwide, like this. But you need to be able to understand the users to be able to capture how to actually provide value to them. If you don't have that, because maybe you are starting, or maybe you don't have a team that does that, or you already have something, actually you probably have intentionally or not created what we call proto-personas. Proto-personas are like an idea of what our users actually are. They are not validated at this stage by the data points that you can get from the field, but they represent already something. And then you need to validate your hypothesis on these proto-personas to actually refine and get better information about your users. So if we have personas or if we have proto-personas, then we can actually get some good information about our users and use this information to actually enrich the result. And with that, I'm going to let Hajer talk about search flow and architecture.
Thank you, Cédric. There is a lot of noise. Let me know if I should remove this. All right, so Cédric went through how important it is to build your persona and also include the user context, business context, domain context into your search queries. Now, usually, let's say you have a business context where you would like to prioritize some marketing strategies, for example. You will need to do some processing after retrieving your search results. You have like the advertisement, organic search results, and so on. Here we are going into more simplistic approach into how LLM can make it easy for us to include the context within the search query in itself and reduce the amount of processing, post-processing that you usually do on the search query. So if you take a persona, it's coming on, connect on your web application, it will type in their input. So instead of post-processing the search results, here we are pre-processing the search results using the context. So the user input will go through, let's say, routing gateway. You can think about it like that. And here you will need to build or what we suggest is that you build different paths for your query. The first path will be for the persona that you have already identified. You know your users, you know your persona, and for those identified personas, so you have already gathered, we expect you to already have gathered context about what their preferences, what's their behavior, what's their priorities in life, what they're looking for usually, and also capture the UBI data, meaning, for example, what type of queries do they usually run? Are they the type of persona that uses, or they know exactly what they're looking for? Are they the type of persona that they always look for specific brands, they want keywords, or they more into navigational type of persona, where they want more flexibility from their search results? And then, as a business, you will need to grow, right? And you will need to also accommodate for search results that are tailored to new users where you don't know the context yet. Maybe you do have some context, and that context, what we recommend here is to not have something like anonymous, completely blank without any personalizations. You can always have personalizations based on the already existing personas, so how the headquarters are, what the trends currently, recently, your customers are looking for electronics versus, I don't know, some fashion items and so on. Or if it is broadcast, for example, online, you know where your users are going to and what type of podcast they are looking for in that point in time. So you can always enrich for the new users as well, and here you will include the market trends, business priorities. Where this context will come from? You're own environment, basically. So you can bring it from external databases, you can store the information in OpenSearch, and build this context included within your search query. And then finally, you will run the search query enriched already with OpenSearch as a search engine. So here we have a couple of benefits that we highlight. So first, you have a tailored search persona for tailored search experience for the primary persona that you're already familiar with, and also the new persona or proto-persona, as Cédric mentioned. And also, you not only including the user context. Here we are taken into consideration the domain and business priority, which is many customers that we talk to, they want to include the business context, but they don't know why or how. And they overlook basically the importance of having the business context besides the user context. So if we take a persona, Sarah, she's 32 years old. She likes good quality products. She's into fitness, travel, and she's mainly shopping online. So Sarah is a persona that we know already. And Sarah comes into our e-commerce applications. She types in black shoes. So here, instead of having Sarah go through all the filtering and looking for type or the brands that she usually likes, we already provide that information within the search query for her. So first, we generate the context for her. So we know her preference. We know how she usually runs their search queries using UBI. We will generate more text to enrich, first of all, the few words that she has, because here, when we enrich with text, we also reduce the noise in the embedding, and the vector search provides us with better results. So that's on the technical level. On the context and search relevancy level, so we complete what she have already started as a search input with her own preferences without her having to type all of this information. And also, we automatically extract the filters for her. And we apply the filters instead of her going to the facets and filter on the brands, filter on the age, category, etc. We already know that she's looking for footwear. We already know she's looking for a female products, unless she specifies otherwise, like saying black shoes for men, for example, or for young children. And then in OpenSearch in itself, so here we provide an example for a canon, but think about it as a hybrid search as well, where instead of running the embedding or generating embedding for black shoes only, you have an embedding of enriched text that provides good embedding quality and therefore good vector search quality as well. And this is something very important to consider when you're running vector search. There's nothing magical in it. You need to make sure that the embedding is of a good quality and representing the information with the most complete context possible, basically. Okay, so from architecture perspective, think about it as a reference architecture, and Cédric will go through a demo of how we implemented this. So again, we have the web application, we have the user coming in, typing their query. Now the query will enter the decision gateway for routing, as we discussed, if it is a new persona or an existing persona that we are familiar with. And here, the logic in itself on how to process this is going into LLM-first architecture. So here we are using Strands agents as the primary planner and orchestrator for this query understanding. If you're not familiar with Strands agent, is an open source AI agent framework. It's based on Python. It's very easy to start with. And basically with Strands, you have three elements. You have the model LLMs, you have the prompt, and you have the tools. And the tools you have already pre-existing list of tools. Otherwise, you create a function, Python function, and you have like a decorated as a tool, and the LLM will automatically capture that and use that function as an existing tool. And also something about strands and what pushes us to use strands is that eliminates the building steps into like, hey, build the flow, explain to the LLM what should we do at the first step, second step, and so on, which tool to use and when. Here, the LLM chooses by itself what's the framework, what's the flow, and also what tools to choose for that specific query. Now, so we are using in the demo Claude 4. It's hosted on Amazon Bedrock, but of course think about it as your own LLM or small large language models hosted on your own inference. Here, the LLM will automatically generate or expand the query using the context that we provided with. Here, we're providing it with a tool, which is a Python function that will it will first extract the filters that have been extract the filter from the expanded query, and it will also construct the OpenSearch DSL query, basically, like the filters and like if it is must or should, and whether the type of query, canon or hybrid. And then the agent will run or use OpenSearch as a tool to run the personalized search and run the provide the personalized search results. It's as simple as this, right? Now, yes, it is simple, but for production workloads, it can be complex to implement this. And it is also challenging to maintain your business SLA service level agreements in terms of latency and so on. So let's say the LLM goes into a loop and thinking and reasoning again and again, what should be the flow, it's losing time, and also maybe the query generation is taking a long time than expected. What would you do? You will lose Sarah that was on the web application in that case. So here, we highly recommend that you build your default path. The default path is where you know what works best with most of your users, have the query already go through the default path by default, get the results as soon as possible, and then with the, if you have an existing persona coming in or even anonymous persona, you'd specify a timeout, your threshold, what's your expected latency. For example, for e-commerce podcast, e-commerce website is like 200 milliseconds, 300 maybe. They cannot go beyond that. Why, for example, if it is a RAG, internal RAG use case, they can go with 1 second, 2 seconds. So here you definitely need, as a business, define what's your timeout. And if the LLM architecture here, LLM first architecture exceeds that timeout, you already have the research results provided by the default path, and you retrieve that. So here you have different benefits. You have your fallback strategy. So you don't exceed the business SLA, so the business is happy, users are happy, happier than spending a lot of time on the web application. And also you reduce the zero results from your search experience. I think with that, we go to the demo.
Thank you, Hajer. So before going to the demo, let's introduce the demo context. So we are going to see an application where we are going to be searching for items in a store, in shop store, and meet our 3 main personas that we are going to be looking at. So we have Sarah, who's a marketing manager, whose interests are in technology, fitness, travel, and preferences are around quality and efficiency, and shops online very frequently. Alex is going to be a computer science student with gaming, programming, and music interests, more budget conscious, looking for deals, looking for discounts. And finally, we have Michael, who likes do-it-yourself projects, gardening, sports, likes also durable items and with good values, and prefer in-store shopping. So for the demo, let me set this up quickly. Where are my displays? Mirror. Yeah. All right. So for this demo, we have a simple application that has been created in Python, and we are showing here multiple possibilities with the persona. So we can go with no persona at all, which means that we are going to be dealing with no query understanding, no query expansion, nothing, just as is semantic search. We can have an anonymous user. We can have our three main personas. The anonymous user is going to have some general interests, like general shopping, standard search without personalization, etc. It's going still to be able to expand based on the LLM understanding of the input, but it's not really going to be like personalized at all. So here we can search for our famous black shoes. And this is going to go through multiple steps. So the first step is going to be the query expansion. We have, so here I selected no persona here, so I'm not going to have any kind of query expansion. So I'm effectively going to OpenSearch and generate a query that looks like this. So this is my black shoes here, computing the embedding through this model. And we have no filters extracted, and then we are outputting only what we want. We found 10 results because this is what we asked for with size equals 10. And we get some black shoes because, well, this is semantic search, so this is not too bad. But it's random shoes. We don't really have anything that's going to be random. So we need to browse in the result as a user if we have that. OK, this is the one that I want. I'm going to look. We have scores that are not too bad as well. We are using cosine similarity, and we have 0.79 best score. It's not too bad. We can have worse than that, definitely, without any expansion. But let's look at what happens when we actually change that. So just changing the context of who the user is going to be providing a different result in the query expansion set. So here, the LLM actually returned these results. So we have expanded the query with something that is very generic. So we have all sorts of shoes, sneakers, boots, Oxfords, etc. So same thing, it's not very personalized because our persona is a generic one. So what we have here is obviously a different query. We have extracted footwear as a category, so this is already something that can be interesting. We don't have any characteristics other than that, so we just have the query expansion. We are still going to go through the same model for the embedding, and we are going to have these search results. So it actually improved the score a little bit. From 0.79, we went up to 0.81. And we are still getting some random shoes, but at least the input has been a little bit more tailored towards looking for footwear shoes, or not for toys or for something different. If we go to other personas like Sarah, for example, let's go there. We are going to get some further personalization. Out of the box, it's going to be looking at the information that we have about Sarah, and we are going to be getting some gender affinity here. Sarah likes athletic, running, sneakers, but also comfortable shoes for professional environments. And here we are going to see so the new query expansion with the filters, and we are going to get some results. So 0.82. First one, comfortable shoes, so not really for the, not sports related, but it's also based on the fact that our data set is not actually targeting footwear for this gender affinity that well. So the input is not everything. The actual catalog and the way that you actually put your data in the catalog is going to be also very important here. So here we are getting some results that are interesting. But if I change that and I want to actually, as Sarah, search for my brother. And the LLM here is going to understand something that's new. We are going to be looking not something for Sarah, but looking for our brother. So maybe we have information, maybe we don't, but at least we have other information. Brother is going to be mostly looking for a male gender affinity, and we are going to start getting some results that are a bit different. So we can do the same thing with all the different personas and start seeing some results that are going to be really tailored to to the different personas. So Alex being a student, we are probably going to get some cheaper shoes, more comfortable. Yeah, so we have sneakers here. Same thing with score relevancy that is high still. That's good. So we have all of that. I can go also with Michael. I'm not going to go through everything. But because we are using semantic search with dense vectors, we can also search with different languages. So I can search in French. And I'm going to get some results there. With the query expansion, same thing, we have black shoes, which is literal translation, and we have something that is tailored to Alex, because this is the person that we have. So this approach is actually very interesting when you really have some information about the user, but you may not have all of that. So here we say, well, we have a persona, we use that persona there. You still need to have an actual user. Remember that personas are fictitious people that represent a group of real people. So you still need at some point to have a link, a mapping between who the actual user is and mapping this person to this persona that is representative of the group of users with the same goals, mental model, and behavior. These models are really good with multiple languages. So I showed French. We can go, if we want, with Japanese, and we are going to get similar results as well. And so you can see that it's taking quite some time. But if I'm going back to my black shoes initial, okay, let's change the input. Okay. Yeah. This one here is going to use a cached AI response. So if you were in the previous session, where there was a talk about semantic caching and caching for LLMs. This one is using a simple exact match with the input and the output. There are other techniques to do that. I recommend watching the video of the previous session if you have the time and you did not attend the previous session. But basically, we can use caching here to improve the speed, because obviously going through the LLM, waiting 1 second or two, this was not taking a massive amount of time here, but in reality, if you have a lot of things, maybe it's going to be a bit more expensive. So caching is going to be part of this setup. Yes. So let's go now with the. What do we have here? This was live demo, and with the best practices for production deployment. Hajer?
Thank you, Cédric. All right, so quickly, how to make sure that such simple solution that you can think of is ready for production. We do have many list of must-haves, fallback strategy I will discuss with you critical path. Here, recommendation is to go with hybrid search, to be honest. That's what we see most of our customers getting the value from. Then optimize the LLM latency with caching caching mechanism, or maybe use also a memory database like Valky. Look for features where you can improve the latency on the inference level. So here, if you are using Amazon Bedrock, we do support a feature called latency optimized inference. It's enable it for specific LLMs, but I think they will increase or increase or add more LLM support for the latency optimized inference. And then optimize, of course, your vector deployment with OpenSearch, apply filters as much as you can, use optimized memory nodes. Of course, evaluate. So here we did not go into deep into how to evaluate this, but the LLM in itself and the strands, they have the feedback loop, and then automatically evaluate basically the search or the final response based on the user input and reason whether that's good enough or not. And then observe, of course. So here we talk about observability. Strands also integrates with OpenTelemetry, so you can already publish the logs, traces, and metrics into OpenSearch and monitor the different latency and performance of the LLMs, but also the response of the LLM. Watch out for frequent updates. This is also something to consider for your data. If you have frequent updates of your data, make sure that you're accommodating for that, whether for the graph, if you're using HNSW, for the vector graph constructions. Also, if you are changing the embedding LLM, make sure that you also reindex the whole data. Otherwise, you you end up with the very bad search results. User re-ranking as well, I think. These are capabilities that are good. They are there. They're easy to implement. So there is no harm to also have re-ranking in your search pipeline before going into very advanced pipelines. Test at scale, of course, and use OpenSearch benchmark. They have released OpenSearch benchmark 2.0, I think, which is very relevant and important to test, especially the scale of your domain and how important or how efficient is your cluster configuration is able to handle the scale of data. So here we leave you with a few resources. So the first one is the Hugging Face public demo. Here we provide you with demos on many strategies into how to integrate LLMs and machine learning with OpenSearch, whether for query rewriting or for semantic highlighting, for multilingual support, for agentic RAG, and so on. So we highly recommend you check that out. Also review UBI if you still did not hear about UBI, you're not familiar what it is about. The OpenSearch 3.2 releases, especially on vector search optimization releases. And finally, the Strands agent, if you are not familiar with the SDK. Thank you so much, everyone, for your time. And yeah, have a great day. I have a question, yeah.
Yeah, first of all, thank you so much for the idea. It's really good, and I could probably go back course to say it's really amazing one. The reason I'm saying that is because many of the users that I'm speaking to, they actually make guidance like this, and this fills the gap. I feel like. Thank you so much for it. And having said that, one of the things that we use for enrichment is beyond the query itself is the filters. There is a filter. So I was wondering, how do you ensure that the filter that is being generated is already present in your OpenSearch indices? So how do you correlate that in your particular recommendation implementation? How do you ensure that they are correct filters?
Yeah. Okay.
So for the filters and ensuring that you have the correct filters, there are multiple things. So first of all, the way that it's done with Strands, we have a prompt that at this time lists extensively and exhaustively all the possible values for for example, the like footwear, like the category, footwear, dresses, shirts, etc. This can be queried. This can be dynamic. It's currently set in our demo prompt, but this can be dynamic. So you can extract from actual data, like what do you have in your inventory? Maybe you want to use only what's in your inventory. Maybe you want to use everything that's possible. I've seen, for example, some companies with second-hand cars, for example. There are two options. You can use the set of second-hand cars that you have in your catalog, or you can use all the possible brands with all the possible models. Right. So two different things that you can have. But basically, yes, this can be completely dynamic. The idea is that the LLM need to instruct the LLM to pick with a specific set of exact matches here. Otherwise, it will create something that may not exist in your result. And also, the filters that we've been showing here are, I would say, hard filters. It's like it's either in or out. We can change that to more soft filters by having some boosting in the search query, things like this. So same thing, if we don't want to be as strict as we were in this demo, we can change the mechanism a bit.
All right. Thank you so much. Congrats.
Any other question?
Yeah, first of all, great talk. I have one question in terms of, like, do you have any recommendations of how to use UBI data as useful inputs for the large language model so that it can generate user-personalized query? Any recommendations there?
So when I mentioned the proto-personas, for example, this is something that can be very common. Even if you don't name that proto-personas, you probably have done that. So this is an hypothesis. So when you create proto-personas, you have an hypothesis. These personas that I showed were proto-personas. We did not conduct user research for that. So you have an hypothesis, and then with UBI, you actually capture the actual behavior of your users. And behavior is an important part of personas. Remember, personas are goals, behavior, and mental model. Behavior is one of the important things. So using UBI, if you can capture the behavior of your users, you can actually refine these personas, validate or invalidate your hypothesis on who your users are, and actually get better personas with time. And if you have a better understanding of your users, you are going to be able to provide better quality results because you understand them better, and you can enrich the queries that way. So this is one way that I'm thinking of. That comes to mind, to use UBI to improve the input that you send to your LLM. Not the LLM itself, but for the input.
Take the UBI data, do some transformation before we send it to the large language model so that it becomes useful user-defining behavior.
Yeah, it's in the input. So I mentioned the prompt for the LLM. The prompt is basically, given this persona's interests, goals, characteristics, etc., expand the query that was this, like took from the input, extract the filters, all these things. So it uses the personal characteristics, including the behavior. So if you refine the behavior, you are going to impact what the LLM is going to do.
Any more questions?
Yes. I didn't hear the question.
I was thinking, the figure seems pretty good, right? Figure conditions seems pretty fine. Question is that, how do we know that those are the right filter conditions, like for different data set?
How do you know that the value of the filter exists, or how we do know that the filter itself exists? Yeah, that's part of what you have already answered, I think, earlier. Here in the demo in itself, we predefine what we would like to filter against. So we don't provide, like the index in itself, it has, let's say, 10, 20 fields. We tell the LLM, hey, you can only generate filters that are related to these specific fields.
My question is like, how do you know those filters are the right filters for the overall recommendation?
How do you know that the right filters for the recommendation?
Yeah, for example, like, how do you come up with a general idea as one of the
I think this highly depends on the business. Like, you mean, how do we know which filter to apply based on that query?
You mean so that's for not for the query. That's right. For the catalog of your items, you need to be able to label your items with the proper results. Is that the question? Yeah. So, I mean, it's always like tuning the relevancy, especially like in e-commerce. It's always like a back and forth between tuning the query itself and tuning what you add as metadata to your catalog. Here we didn't talk at all about that part, but this is definitely something that, especially in e-commerce, you have to do a lot. That's why most of the time you change things and then you reindex your data every day or every week because you tune things in your catalog. You don't only tune the query. So this is something that's maybe not only specific to that, but that's, e-commerce is known to have this kind of approaches. more generically, this is not something that we see very frequently. But yeah, this is something that was not addressed by our talk here. Yeah, so.
Can I add to that?
Yeah, please.
So I do have a customer where they looked at their last 100 queries and they found most of their search terms were brand, like Nike black shoes or Dior perfume. So they actually found that 60% of their top 100 queries was actually brand names in the query itself. So they identified brand as a filter when during query expansion they applied the brand as a filter. So again, LLM is doing the job of identifying that Dior is a brand and Nike is a brand. But then once you do that, then we can apply the filter. But I think color and gender is a very common.
Yeah.
Yeah, I think it depends on the business. Like, it's very tailored to the business. Like, for example, podcast online application will apply different filters than an e-commerce business. It's highly subjective to.
Analyzing the user behavior.
Yes, yeah, that's.
Queries and query analysis.
Yeah. That's definitely part of the head queries analysis.
Yeah.
Is context built-in part of OpenSearch as the body?
No, that's on the LLM level that we have built that one. So yeah, it's the agent that decides basically how to enrich the query, what context to use, and so on. Sure. Thank you so much. I think we'll be around if there is any further questions. Have a great day. Bye.
Thank you very much.